All right, so today we're going to be doing a review of limits involving infinity. That's what we're going to begin with, and we're going to go on some more limits. So on all of these, we really got to be thinking our end behavior, really what's happening as we're going further and further to the right, or what's happening as we're going further and further to the left. All right, if you notice on all these are limits involving infinity. X is always approaching infinity or negative infinity. Okay, so like I said, it's really about the end behavior, your rational functions. All right. Do we have a horizontal asymptote we're approaching? Do we have a natural log graph? Okay. What is that going to look like as we go further and further to the right, or possibly further and further to the left? All right. So think about what these graphs are doing. Are they going up, down, what have you? You guys just kind of hit the pause button, write all these problems down, try them out yourself, and I'll be walking you through them all. All right. All right, so let's start off over here with A then. Hopefully you guys gave these a whirl. You remember what you're doing. So this is a rational function. All right, I'm looking at my degrees. All right, my degree is the same on top as it is on bottom. So we have a horizontal asymptote at the ratio of the leading coefficient. Leading coefficient on top is 3. The leading coefficient on bottom is 1. So there's a horizontal asymptote at y equals 3 over 1, which is 3. Okay, another way to think about this is ruled by. So on A, it is going to be ruled by, I should say our end behavior is really going to be ruled by our most powerful thing on top, which is going to be a 3x squared. The most powerful thing on bottom is an x squared. Okay, that's going to reduce then. My x squareds cancel, which is just 3. So two different ways to kind of think about this. You're ruled by, or where is your horizontal asymptote happening graphically? B, we could kind of do a similar thing here. We could begin with ruled by for our end behavior. Okay, my most powerful thing on top is going to be x to the third. Most powerful thing on bottom is x to the fourth. Okay, so that would reduce to 1 over x. That's essentially what our end behavior is going to look like. So if you think about the rational function 1 over x, it does have a horizontal asymptote at 0. Another way to think about this was my degree is bigger on bottom. All right, if our degree is bigger on bottom, we're going to have a horizontal asymptote at y equals 0. So this doesn't really matter if we're approaching positive infinity or negative infinity on this one. It would be the same either way. It's going to be at 0. Our next one, all right, if you notice our degree is bigger on top here, all right, so we do not have a horizontal asymptote. You have to go with our ruled by on this. Okay, so for C, this is going to be ruled by. Our end behavior is going to be x to the fourth over x to the third, which is really just x. If you think about the graph y equals x, we go up to the right, down to the left. All right, so that's essentially what's going to be happening on our graph. There's going to be lots of crazy stuff happening in here, maybe even an asymptote or two, but we don't really care about that. What we care about is our end behavior. This one specifically, our right end behavior, because x is approaching infinity. So as x goes further and further to the right, y is getting higher and higher. So we're going to be approaching infinity. All right, on D, once again, my degree is bigger on top. All right, so if my degree is bigger on top, there is no horizontal asymptote, so we must be thinking about what is ruled by. Our end behavior is going to be ruled by x to the fourth over negative x squared. All right, so that's really important. A lot of people will forget about that negative. Make sure you carry that with it, because now this is going to reduce to negative x squared. All right, so negative x squared, our right end behavior is going to be going down. Our left end behavior is going to be the same as the right. So on this problem, we care about our left end behavior because x is approaching negative infinity. So as we go further and further to the left, what is happening here is y is getting lower and lower, so it's approaching negative infinity. E, actually most of the rest of these we're gonna kind of change up now. I'm not really thinking ruled by, I'm not really thinking end behavior, or I should say I'm still thinking end behavior. I'm not thinking my degree is bigger on top, bigger on bottom, what have you. I gotta be understanding what the natural log of x plus 2 looks like, okay? So keep in mind, the graph of natural log of x, all right, would have a vertical asymptote at y, or x equals 0, and it's going to go up to the right like that. Now this minus 2, all that's going to really do to my graph is shift it left 2. That does not change my right end behavior at all. My right end behavior is still going to go up to the right forever. So this is going to approach infinity. All right, down here we're looking for our left end behavior. I need to be thinking, what does the graph of e to the 2x look like now? Well, remember, e to the x is an exponential function. Okay, it has a horizontal asymptote at y equals 0. It's going to go up to the right forever. Now that 2 is really inside my function, right? So this would be inside. If I have something in front of the e, or adding or subtracting at the end of it, that would be outside my function. That would be up and down movement. In my exponent, that's going to be kind of considered inside my function, so it's going to be horizontal. So this is actually going to be a horizontal shrink by 1/2. All that does is make this a little bit skinnier, okay? It has no effect on my right end behavior. My right end behavior is still going to be going up to the right forever and ever. So this is going to approach infinity. All right, letter G. Over here we have pi to the negative x. All right, so pi is just a constant. It's very similar to e. All right, so instead of 2.718, this one's going to be 3.14. So pi to the x really is going to have a horizontal asymptote at 0. It's going to go up forever and ever and ever. That negative, what that does now is it's a horizontal reflection. So we're going to reflect across the y-axis. So now my graph will look like this. Okay, so now I do care that I gotta go back here. So as we approach infinity, as we go further and further to the right, we're going to get closer and closer to 0. I screwed this one up. I even talked about as my left end behavior. I gave the answer as if it were my right end behavior. Oopsies. This guy's going to be a 0 right there. Okay. As we approach further and further to the left, we get closer and closer to that horizontal asymptote, which is at 0. This one. All right, let's first talk about e to the x. Okay, so e to the x has a horizontal asymptote at 0. It's going to go up forever that way. Okay, next I'm going to talk about my negative. So the negative is just a horizontal reflection. Okay, so I'm going to reflect across the y-axis on that one. Okay, then the last thing I'm going to do is minus 3 is really just shifting everything down by 3. So I go down 1 and 2 and 3. All right, so now my graph's going to look something like that. Okay, I've got to pay attention to my end behavior, which one I want, obviously. So this is going to be my right end behavior. As we go further and further to the right, my y value gets closer and closer to negative 3. So this guy is going to just be equal to negative 3. Another thing to think about, like e to the negative x, as x gets really, really big, what's going to happen is you have a really, really small number. This part essentially approaches 0, and you just be left with negative 3. All right, so last one, guys. This one's kind of funky. You don't normally see ones like this as we're looking for end behaviors. So here we want the left end behavior. Okay. This one's going to kind of be ruled by one way to think about it, a square root of x on top and an x on bottom. Really what happens with this is the one on bottom is more overpowering than the one on top. So it's like basically our degree is bigger on bottom. Okay, if our degree is bigger on bottom, we have a horizontal asymptote at y equals 0. All right, guys, so I hope this all makes sense. Hopefully that one didn't screw you up too much after I mixed up which one I was doing. We're going to go on to limits at specific points next. All right, so hold on tight.